Okay, welcome back. So I want to just very quickly recap where we were the last time. We introduced the simulation Z. This is also called a standardized statistic. Now, one thing you have to be clear is as class progresses, there are going to be many statistics called Z. Okay, they are all called Z, and but they are different depending on the context. So the context will make it clear what Z we are talking about. I'm just letting you know upfront. And I'm calling this sim, I call this SimZ because it's based off the simulation. Now, if you have done your homework, which I know most of you have, and I'm happy to see that, there's something called theory Z, right? And I'm not sure what some of you are calculating there because I've not taught you yet. But the good thing is, if you did SimZ, theory Z and SimZ are close. But theory Z has a slightly different formula we'll introduce today. Is it clear what I'm saying? SimZ was last week. So SimZ is defined this way. Observed statistic minus null hypothesized value over ST of the null. Now, we like to use colors in this class because it does help. What color do we represent the observed statistic by? Very good, red. What color do we represent the hypothesized long-run value of the parameter? Blue. What color do we represent the standard deviation? Very good. Actually, I like the way you all are saying it, like blue, red. Like, in other words, it's coming so naturally to you, which is good. Notice there is no fourth color here. What was the fourth color we used, and what was it for? Yeah. Purple, and that was for what? The p-value. The p-value doesn't enter into the z statistic. You must understand that. The p-value and the z statistic are two separate ways to evaluate strength of evidence. They are, of course, telling you the same thing. If not, you can just go home and drop this class because I'll be teaching you nonsense. All right? The p-value and the standardized statistic, they tell you the same thing, but they're not the same thing. And this formula involves only three things. It doesn't involve p-value. The p-value is another direction coming to tell you the same thing. That's why you have a strength of evidence chart that uses the z statistic and the p-value. They both tell you the same thing. Now, I told you about the seesaw last time. As your z statistic gets bigger in size, your p-value will drop. They have an inverse relationship. All right? But they tell you the same thing. All right? So that's the formula for SimZ, which you have correctly told me. So today we will directly tell you about all these while we have been using a simulator, right? Whether it was that we always use an applet to simulate and things like that. But people have wanted to do this kind of thing for a long time. For a long time, like I'm talking about like centuries, right? For millennia, people have been wondering about how likely are you to see something like that if status quo. So these ideas are not new. But computer technology did not allow people to be able to simulate. So what did they do? All right. The one thing good is that intelligent people have always existed at all times. I think there are more now because there are just more people. But so they actually found a way to do this. So this is where we're going to start today. If you look at your notes, we are at the last part where I introduced theory-based methods. All right. Okay, here it is. Did you see so far that all the plots we have in class, every time we use the simulator, we get a bunch of dots, right? What was the shape of that distribution? It was always like a bell, if you remember. It always looks like a bell, and that's true. The null distribution that you make is usually bell-shaped. It is always centered at the blue value. Remember, that's a homework problem. We always ask, where is it centered at? Where is it centered at? Where is it centered at? It's centered at the blue value, which is the hypothesized value. And we've also learned this last week. The more your sample size, the larger your sample size, the more focused the null distribution becomes. If you check Scratchpad, you'll see that. It's like you squeeze it in, all right? So before the advent of computing, it wasn't possible to use simulation. I mean, in theory, you could do it, Take a coin and flip like crazy 16 times and do this 1,000. And nobody wants to do things like that. Although I must say, I know of one example where someone actually demonstrated what happens when you simulate thousands of times. It took place during the Holocaust in a concentration camp. Somebody flipped a coin literally thousands of times to see what the long run effect actually was. This is actually a thing. So it is possible to do by hand, but nobody want to do that, so you use a computer. So before people had computers, they relied on something called the central limit theorem. All right. You don't want to remember this name, it's okay. It's very famous. But the central limit theorem actually allowed you, without using simulation, to tell me what the SD, that number in green, was. You will notice that that number in green, that SD, only comes about after you simulate. Let me ask you a question. The red number and the blue number, do you need a computer to tell you what those are? The red is the observed, the blue is the hypothesized. Do you actually need a computer? You don't. The red and the blue, red is what you observe, blue is what you say status quo is. You don't need a computer to give you those two. The green number you do because you simulate, and then from the simulations, you get the spread of those values you need to simulate. So if you have a green pen with you, I would actually ask you to circle this green. This is the SD, but it's a theoretical SD. Did I use a simulator today? No. This is a formula that if you plug in, and do you see what this formula is? Pi, 1 minus pi over n. Please look at it carefully. I have students who think this is an n, this is also an n, and then they cancel these two. Please don't do things like that. Right? This is not an n, this is pi. And what color do we color pi in this class? Pi is the hypothesized value, and pi should be, which color do we use for pi? It's where the simulation is centered at. Blue. In other words, this pi that you had from long ago is nothing new. You use that hypothesized pi, dump it into this formula, that gives you your SD without needing a computer. This is the theory-based method you're talking about. So it's based off the normal curve. Have you heard of the normal curve before? So this is called the normal approximation, and that gives you this. So let me show you. I'm not going to have you use the applet to see this, but you will see that the applet has the option to check one more box. We have never done this. You don't need to. I'll show you what happens. If you check normal approximation, do you see something nice happens? These are simulations. You can see a little bit jagged. All these dots are what you get when you simulate. Do you see a perfectly drawn bell superimposed on this graph? Do you see that? That perfect theoretical bell is the normal curve. So do you agree that the normal curve quite well approximates the simulation? Do you agree? The normal curve kind of tells you what you will get when you simulate. So it's really freaky, because you don't even need to simulate. You kind of know where your dots will be. I don't know whether that freaks you out. It should. This is crazy. People have known this for hundreds of years. All right? Hundreds of years. Computers at this level of power are just 20 years old, maybe. I mean, computers have been around longer than that, but at this level, they can do it in the classroom and simulate so quickly. It's just about 20 years. But people have known about the normal curve for hundreds of years. It astounds me. Long before America was a thing and all that. Honestly, it's crazy. People have wanted to know. So this shadow that you see is the bell curve. You get that when you click on this one. So a few things happen. First of all, nothing here is different. The center point is here. Whether you use theory to talk about it or simulation, there's a center value, there's an observed value. This is a two-sided test. And when we get a p-value, we count the dots that are as or more extreme on both sides because it's a two-sided test. Remember two-sided test from last week? All right, you count the cases. So in other words, there were 233 cases here. You can see dots here. And there are 234 on here. You add the two together, that gives you the p-value. This should be colored what? This is not supposed to be red. What color do we use in this class? Purple. This is the simulation-based p-value. We know a simulation why? Because it's based on dots. There are 1,000 dots in the picture. All right? These things have to be clear. So, is there a way to get these the theory p-value. You just told me, I just told you there's no need to simulate if you're going to use theory. How do we get rid of the dots? Well, you go to the curve. Now, I want you to stare at this curve carefully. Do you see there's a p-value here that's in another color? Confusingly, it's green. It should be purple. All p-values are purple, but this p-value is not the same as this, but it's close. This is the theoretical p-value. Now, I want you to look at this graph. Can anyone tell me? If you didn't have the dots, but you only had a smooth curve and you have your two vertical red lines, what do you think the computer is doing to give you a p-value that is equivalent to dots? Do you know what I'm trying to say? Look at this graph. Can you give me a four-letter word for the thing that represents the p-value in the theoretical context? So the dots are gone. There's no more dots. The curve remains. The red line remains. What do you think is 0.439? Where is that coming from? What is the computer calculating to give you this 0.439? Does anyone have any bright ideas? Look at the picture carefully. What has taken the place of the dots? Imagine the dots are gone. Only the curve is there. Where do you think the p-value is coming from? Does anyone know? I'll let you think about it for a bit before I give you the answer. Anyone want to try? Where is the p-value coming from? It is not from dots. Imagine you cannot simulate. You cannot simulate. All you have is the smooth curve. Look at the picture. Where do you think the computer is getting the p-value from? It's a small word, just 4 letters. What do you think?
Like the mean?
It's not the mean, right? It is some entity that you get when you do math in school and you learn. Something about the graph can calculate and become like a surrogate for the p-value. The concept is the same, but it's not a fraction of dots. Anyone know where I'm going with this? Small word, 4 letters. Okay, one more hint. It starts with an A, this word. What do you think people of old found when they couldn't simulate, but they had the smooth curve and they wanted a p-value? A dash dash dash, 3 more letters. They looked for look at the picture, right? The answer is in the picture actually. What am I getting at? The A what? P-value is represented not by dots in the theoretical context, but by, I think I got the answer. Anyone want to try again? Four letters starting with an A.
Area.
Yes. Area. We know this how? Look at the picture. If I took the dots away, what's left? Can you see some orange thing here like that? Wouldn't the area of those orange regions kind of give you the fraction of dots that are as or more extreme? So that's what people used. They used area instead. So the theory-based p-value is not based on counting dots, but on area. And now, here is theory Z, finally. I want you to stare at the formula carefully. P hat minus pi over this thing. Remember this SD I told you about that people could use in a formula without having to use a computer? This is the green number. Now I want you to tell me, you already told me just now actually, what color do we use for p hat in this class? Observe, it's always red. This is hypothesized, it's always blue. And what comes at the bottom of SimZ? Something green. This is the SD, but you know this? It's not something you get from a simulation. You get it using a plain formula. You don't need a computer. Why do I say you don't need a computer? Do we have pi? We just used it on top. We have pi. Do we have a sample size? Of course. You know how large your sample was, so you can calculate this. So the last few slides will be on the comparison. How good is the theoretical comparison to the simulation? They are very close. If you look back at the picture here, do you see SD 0.029? Do you catch that? This one is what we color green in class. This is green, SD.
This is simulation based. You know it's simulation based because it's sitting next to the dots. This is not theoretical. This is simulation. This is from the simulation. So this is green as well. Anything SD, I'm going to color green. All right. So 0.029 is the simulation base. Let's calculate how good the theory formula is in approximating this standard deviation. If you use this formula correctly, this case was a pi equals 0.5 case. I'll tell you the background of the study. We didn't have time to go over what the data was. It was basically someone wanted to see, at Halloween, it used to be the case, it still is, but not as widespread. People would go trick-or-treating and all that. So someone wanted to know, if you offer children a toy or candy, which would they choose? Because why not? Right? Everyone wants to know that, apparently. So toy in one hand, candy in another hand. So you want to know what the child will choose. And if there's no preference, in the long run, there'll be a 50-50 split once again. So this is another 50-50 example. That's why pi here is 0.5. This is a Halloween example, and they look at 283 children. So if this is a demonstration of how you use this formula, you take pi, 1 minus pi over sample size, take the square root, and there's the number. Are they close? Very close. So this, again, is freaky. Theory, it lines up with simulation. You don't even need to simulate, and you can get the SD without using a computer. If you didn't have a computer, you didn't know this. That number comes from the computer simulating. If you didn't have a computer, you'd have to use a formula, like what people used 100 years ago. All right. Now, what was the p-value? Now, I want you to tell me the just tell someone, just shout it out. What is the simulation p-value here? Which number is the simulation p-value? Anyone? Yes.
0.46.
Correct. 0.467. We know this how it appears here. It also appears here, and it should be in purple. That's right. I have introduced the theoretical p-value. Did anyone catch me when I said that? Which one is the theoretical p-value? Do you see it on the screen? Which one is it? It's something close to the simulation p-value. 0.439. This one. All right. There's something here called Z. This is theory Z, not sim Z. Why? Because it's sitting near this normal word. Everything here is theoretical. All right. So we will finish our comparisons. You will see that the theory-based and simulation-based p-values are also close. Very close. What was sim Z? How do you find sim Z? Revision from last week. Sim Z is always found by taking what you saw. I didn't tell you what you saw. In the sample, 52.3% of the children chose candy, I think. That's your observed. Status quo is 50-50. If children have no preference between candy or toy, then they will choose either with 50% chance. But there was a slight preference for candy, so 52.3%. So observed minus hypothesized over SD. Everything that's simulation, you keep on the simulation side. Now we will do the counterpart. How do you calculate theory Z? And this will help you in your homework. That's why I made the homework due on Thursday. Right? Because theory-based Z would be this. P hat minus pi over the square root. Okay, so do you notice that they share the same numerator? Sim Z and theory Z have the same numerator. Red minus blue. And actually, the denominator is green. It's just, where does that green number come from? In simulation, the green number comes from the computer, from the screenshot. In theory, you calculate the green number, but it's a green number, it's an SD. This is an SD. It's not a different entity. It's just that this comes theoretically, not from looking at the simulation. You are able to calculate this in complete isolation. You don't need a computer. You need a calculator, okay? But you don't need a computer to do simulation because there's nothing here involving simulation. Also notice how close these two are as well. So when is theory going to line up so well with simulation? You are actually only supposed to use a theory-based method when one thing has to be checked. In other words, it wasn't all fun and games. There were limitations 100 years ago. You couldn't always use a theory method. You could only use a theory method when something was true about the data. This is what we call a validity condition or a disclaimer, if you like. The word validity condition is going to come up many times in class. Also, I think before I forget, someone has asked about when's our first test. I think the syllabus says week 5, but because of the snow day, I'm going to move it to week 6. Is that okay? And I usually try to do tests on the last class of the week. So week 6 for you is Wednesday. I will give you more information, just giving you a very early heads up. This is week 4, all right? So the disclaimer is this. You can use a theory-based method. In other words, they will agree very well. Simulation is always valid. But theory-based method needs something. You need at least 10 successes and 10 failures in our sample. What do I mean by success and failure? Let me explain. You know that a proportion is always based on a binary response. Did the child choose candy or toy? All right. You have to pick one direction as a success. If you say candy is a success, it means you need at least 10 children choosing candy. And a failure would be choosing a toy. You needed at least 10 choosing candy and at least 10 choosing a toy. If you have that, you are free to use the theory method. If you had a very small sample, 5 children chose candy and 3 chose a toy, you should not be using the theory-based method. You should simulate. Am I making it clear? This success failure thing is something that is a little bit hard for students to get at first blush. You pick something as a success. It doesn't have to be candy. It could be toy, but pick a direction and stick with it. There's this candy Twix, I think. What's the slogan? Pick a side. Right? Yeah, pick a side. So which one's a success? Right? Yeah, don't get me started on America and its passion. I would say passion for candy. There are whole aisles of candy. Right? In Malaysia, where I come from, and the candy is so big. The package is huge. Right? Very bad. Right? And it's full of look. If you look at the side, the ingredients will scare you, right? There's like 60 things you can't even pronounce. Right? So anyway, so what am I saying? Yeah, okay. So that basically a failure and a success is what you want to define, but you pick a side and stick with it. That's it. So since I told you p-values are areas, let me tell you, we're going to do some activities. They're pretty fun, actually. How do you find these areas? We are not going to use the applet to tell us the answer. I think that's doing a disservice to the class. You have friends in other sections, I believe. They are wholly and solely dependent on the applet. If the applets are gone, they cannot find a p-value. They have to use the applet. They are not taught how to do this. So in a way, in my section, I don't know whether they call it as a privilege, but I do teach students how to use the table so that you're not dependent on the applet. I'm not trying to be cruel, but it's just that I think if you graduate from college and you have a statistics subject in your transcript and you don't know how to use a statistical table, I think that's a problem. That's what I think anyway. So it's not hard. All right. So where is this table found? Let me show you. I also strongly recommend, if you can at all, try to print out one page of this table. Well, it's 2 pages. Print out a physical copy. You know what? You'll be using it a lot. It is very irritating to use something online so much. It's just one piece of paper. I think the world can withstand that. So one piece of paper, hold on to it. If you want to laminate it, you can, because it can get pretty dog-eared after a while. So where is it? So if you go to our page, you will see Z table. That's the one. Z table. Okay. So what does it look like? Now it's very unfortunate that when I made this Z table, I colored this blue. What should I color this? Areas are p-values and it should be colored. What color do we use for p-value? I want to make this a thing. P-values are always purple. So imagine in your mind that this is a purple area. Okay? This table is really easy to read. It gives you areas that are shaded. It gives you p-values. So Do you see Z? There's a column here like that. Depending on your theory Z that you calculate, you would check the table and get the area there. So for example, let's say you calculated your theory Z to be minus 3.1. Where's minus 3.1? Do you see minus 3.1, 0 here? Now, do you see a 0.001? What is this? This is this area. This is shaded because it gives you these areas. This is 0.001. Is this okay? Can I ask you another question? What will be the area? What will be the purple area if my Z I calculated was minus 1.76? If let's say my theory Z turned out to be minus 1.76. Yes, actually, I think it's almost right wrong. Minus 1.76 belongs here. Did you see that? That's the purple area if you saw a Z like minus 1.76. Now, this was all negative. What about if it's positive? Well, if it's on the other side, you turn to page 2 of this table. This table has 2 pages. All right, here's the other side. Do you see that the area now is more? Because you've gone to the other side. So if your C is on the other side of 0, C is all positive now. So if I saw a Z like, I don't know, 0.57, what is the purple area? 0.57. 0.7157. Yes. 0.715. That will be the area on the picture. Now, here's one small twist. You don't always want the area on one side like that. You always want areas in the tails. The table does not directly give it to you unless the tail was on the left. So let me ask you a question. If I wanted the area on this side, what do I need to do? Now, you need to know one fact. The total area under the curve is, anyone want to guess? If you look at the table, can anyone guess? The total area under the bell is what? Anyone have any guesses at all? What is the total area under the bell? No, that's a good guess. Sorry, I didn't mean to laugh, but that was a very good guess. It's not 2, but looking at the numbers and the trend, can you guess what the total area under the curve is? 1. Good. It's 1. If I told you the total area under the curve is 1, and you know this area here, can you give me the area on the other side? You have to do 1 minus. All right? And I've learned something from bitter experience. Use money. Right? If something costs 60 cents, although very few things cost 60 cents now, and you have $1 to spend, what do you get in change? 40 cents. How did you get that? Subtract 1. Yeah. Somehow when it's money, people can see it. But when it's an area, I can't see it anymore. I can't. It's the same thing. The total area under the curve is 1. This table only gives you left side things. That's why the picture is there to help you. This table only gives you left areas. If you want a right area, you do 1 minus. All right. With that in mind, I want you to do this exercise. Have your Z table accessible. If you want to print it out right now, you can on the school computer, but you have to connect using the school computer. I don't think your private machines reach that printer, unfortunately. So you'll have to. I want you to answer this. Just tell me what the shaded areas are based off the Z table that I have just taught you how to do. Ready? Now, I am giving you Z values. Did you notice that? I'm not asking you to calculate anything. Z is given to you. Use the table.
It's just like that. Yeah, so if you're oh wait, oh yeah, 261. Yeah.
Just over here.
Yes, like.
What's the next thing? 1.33.
So.
Yeah.
Yeah.
And then it is 1.7.
Monster.
3. Oh, it's just one.
Yeah. Well, actually, I would have thought.
I think I got it. Oh, 0.7, if you fine. I think you can.
Exhausted. Morgan Wilson. Like they're playing, like they're sit there.
Okay. Can I ask you all to contribute your answers here? I have put the problems from easier to more difficult. This is the most direct because you don't need to do anything. The table directly gives you the answer. Now, you can't type here, this is a picture, but can you type your answer here underneath, right? I made a space here. What is the shaded area when z is negative 0.64? What is it? And we'll check and see whether that was correct. What is the shaded area when z is minus 0.64? 2611, let's see. All right, thank you. So let's have a look. So where's the table? Oh yeah. So negative 0.7, hold on. Negative 0.64 negative 0.64, correct? 2611, excellent. Did you get that? Did everyone get that? Right? All right, this is step one, the most basic thing you could do. Now, can someone tell me, this is only a slight twist, what is the area now on that side when z is 1.38, I think? Is that what I said? 1.38. Okay, this answer needs some processing. Do you know why? Okay, I'll show you why. Let's go to 1.38, all right? Let's go to, does anyone have a different answer? If you don't agree with this one, does anyone have another answer? All right. Notice my question is, what is that area? All right. So look at the table. 1.38, 1.38. Yes, you do see a 9162. But, so 9162 is half the battle not the whole thing. 9162 is what area? Is it the area that I want, or is it the area on the left side? See, look at the picture. The picture says that's 9162, which means what should you do to this answer here? You need to process this by doing something. 9162 is the area on the left. Okay, I'm gonna say this. You know that song? Y'all are so young. Do you know the song on the left, on the left, on the left, on the left, everything on the left? Okay, that one. So on the left, on the left, on the left, everything on the left, on the left. Is it something? Is it a breakup song? I don't know. I don't listen to that kind of music, so I don't know. I know it's very, very popular. Was it about breakup and then you're packing things? Oh, it's not? Okay, never mind. So, but this table is on the left, on the left, on the left, on the left. It only gives you things on the left. If you want something on the right, you need to process the answer. So you take 1 minus. Now, can I keep that old thing? Can you show me your work? In other words, the work is actually important. So this is 1 minus, now what was it? 0.9. Wow, my brain has left for the day. What is the answer? 9162, right? Thank you. So you see, sometimes the table doesn't give you exactly what you want. You need to do one bit of processing. Okay, little bit. Let's finish this one. What is the total shaded area here? Let's see what you did. Now, do you see, this would be the case when you have a two-tailed test. So what does the table tell you? Negative 1.73. Let's always go for the most basic thing first. Minus 1.73 would be on this side. Minus 1.73. Okay. Do you see a 0.041A? All right. And I think that's what you have on Scratchpad. But is this the answer that I want? What do you think I'm going to ask you to do to this answer? Yes. Why? This is exactly the same area what on the other side. You multiply by 2. See, the table doesn't know if you want two sides or one. The table only does on the left, on the left, on the left. Yeah. So the things you have to do as a professor, right? But anyway, so that's your answer for this one. So can you now answer another one? Now, this one, I think I'll be very happy if someone can figure this out. It's not very hard, but there's two ways to approach this problem. I just want to see if anyone, first of all, can get an answer first. There are two ways to look at this, and I don't know which way works for you. We will see. Does anyone know the answer for this? It's something quite, it's a bit bigger than this. The answer will be bigger than this, but not more than one. Anyone want to try? How do you do this problem? Right? How do you do this problem? Maybe I'll give you a hint. I'm going to teach it using a new approach this time. Although this is positive, can you pretend that you're working with negative 0.59? Can you do that? Why not? Because I didn't write this value here by symmetric. So this is minus 0.59. If you did that, could you answer this question? All right, give it a try. I know you calculated a z that's positive, but you in your mind, you can flip it to be negative. Therefore, what would be the total shaded area here? Right? Show me your work. Okay, something times 2. Right? Okay, let's have a look. I told you, although you calculated a z that was positive, you can negative it for the table's sake. So go to minus 0.59 on the table. Where's our table? Minus 0.59. Okay. Okay. Do you see 2776? That's half the battle. 2776 is only going to give you the on the left area. But you want more than that. You want both sides. So you multiply that by 2. So let me go. This is the hardest thing for today. That is it. You'll be surprised how mind-boggling this has been to previous years of classes I've taught. I don't know why it's so hard, but maybe it's because you are not used to using tables or something like that. So let me go through this again. If the situation is such that you are given a z value or you calculate a z value that's negative and you want this area, there is nothing to do but just go to the table. No processing needed. All right, this is like not even heat and serve. Open package and eat. Right? This is heat and serve. You have to do one thing. You have to heat. You have to do something. All right, little bit more. If I want a z that's positive and I want the area in the tail here, unfortunately, the table is not 100% aligned to give you areas on the right. It gives you areas on the left. So you just go refer to, actually, I don't know how your mind works. If you are sharp, you'll realize that actually, could I pretend that it was negative anyway and just get the area on the other side directly without doing 1 minus? So I leave it to you what method you want to use. You can also do the 1 minus way because if you look at 1.38, that gives you the area on this side. We take 1 minus. The whole point is we want areas in the tails. Okay? And then when you have a two-sided test and you want p-value that's on two tails, work one tail at a time. If it's negative, that's direct, that's easy. If it is positive, you can make it negative if you want. Find this area, multiply by 2. So now that we have done this, I will give you immediately something else to practice here on another sheet, all right? This one, you will have to calculate theory Z. I want you to practice calculating theory Z because you have not actually done so yet. Once you have the Z, then go do this step, the table, all right? 1, 2, 4. And as usual, let me give you the colorized version so that it helps you to visualize what it is that we are doing. Okay, here's the color version.
Do you want to write down? It's gonna be P. It's giving you values. So we're gonna put the numbers in. Yeah, so it's gonna be 0.625 minus 1.
Remember, theory Z is red minus blue. All right.
It's 0.7.
If we use the null, what else is that?
It says that both some value.
I wouldn't use that one. It's all like those.
Right, it's not. And it's 0.625. Right, 1 minus second point over square root of 134 times 1 minus 0.7 over 34.
Now, if you have problems, just give me a shout. All right, I'll help you. Right.
Yeah, and that's gonna give us a thing.
The theory.
So.
I think it's all with calculating.
Gotta do that.
We're not supposed to use the non because based on the alternative.
Oh no, sorry. When it says based on the alternative, it just means that the actually I've already shaded it. Just ignore this line. Okay, this I already shaded it to help you because if you can see if it's a left side, then it's a less than. If it's a right side, it's a more than. So that's okay. Just leave it like that.
I understand. Yeah.
Where's the fractions? Oh, yeah.
I've always said like that also is like leftover. Like,
Oh. Yeah, it's right. So once we get the theory Z,
Yes.
you want us to find, like,
That's right.
and then you go and put it.
Yes, so once you calculate theory Z, make sure you round to 2 decimal places. You know why? Because the table only works up to 2. Then go use the table to give me the area and then the p-value. Now, if you don't like the area step, you can straight go to the p-value. The p-value is an area. So you have to interpret what I'm saying, okay? Get the area first, and then answer the question, what's the p? The p-value is either 2 tails or 1. The table only gives you only areas on one side. So you have to process your answer, okay?
Oh, and then the p-value.
And the first one.
I don't know if you.
No, I didn't give the formula for theory Z. Do you know what the denominator is in theory Z? Square root what? It's very faded, but I think.
Because maybe it's in your because look at the areas of purple theory p-values. Because Robert is like, oh, the only way to calculate a p-value without the dash is by doing each.
Right. Yeah, let's double check it. Oh, yeah, I think you're right. I think
It'll be different when it's two sides.
yeah,
Because you'll have to add
So
both
please,
sides.
let me know if you have problems with
this
it.
was the area to the left and the shaded. So this, like, the second one is all. That makes sense. So all we would do this again. So. So that means area one is, so this is me. It's this way. And this is what. So this is.
Yeah, so what area?
Oh, I see.
Oh, so
Because there's only one. Some processing is sometimes.
4.16.
Okay, anyone else?
Maybe we can find one here.
Okay, so.
Yes, yes, So. And that's the left side.
Now, don't worry about the last step. If you all don't know how to do the area, just get the area shaded.
But the left of Z
Shaded area.
would be what? 0.4364. Or point, no, that's right. So like this with this, I think so. Value. But my question is, since this is the shaded, this is gonna give us a shaded. No, so that's you've got shaded. That's why. Wait, so you get this one, well, sometimes it'll go on to period. So actually. If it's not the area to the left, then you have to like subtract the multiply. Like, I guess.
So in this case, that would be that one is the indicator. See, sometimes the area is not okay. You see, the table, for example, the p-value is always these shaded areas. But the table doesn't give you this. The table doesn't give you this. It gives you something like these. So you need to process the p-value is this area. It is this area. But the table doesn't always give it to you in this form. You need to do a little bit of processing. Okay, little bit. Now, as I said, if you do not know how to do the p part, leave it alone. Just answer the area parts first. Okay?
Yeah.
Okay, so we don't get too far ahead of ourselves, or as we say, but don't get ahead of your skis or whatever that is. All right. Can I have you show me the answer for the very first question first? What's theory Z? All right. Theory Z is something minus something over SQRT something times something over something. Okay, can you put in the somethings? Yeah. Anyone want to show me your answer?
So times 2. Yeah, then you would. And you.
That's right. 0.625 is your p hat. Good. That's red. And what's blue? 0.7. Now, if I didn't use colors, could you have known this? You must slowly try to go away from the color. Not yet. I'm still easing you in. So it's p hat minus pi over the square root of what times what? Remember the formula I gave you in the slide? Let me go back to that formula in case you don't know what I'm talking about. The formula was here. Do you see p hat minus pi over square root pi 1 minus pi over n? That's the one.
These are all 4. I just did 8.
Oh, okay, thank you. This is correct, but I want the class to see the work. So I'm going to take this away. You know what you should do? 0.7 times 1 minus 0.7. Did you see that? Pi, 1 minus pi. And we know pi is the blue number. Okay, so can someone go calculate what this is? Oh, thank you. Okay. Pretty small. Did another group get something like this? Just to counter check your calculations. Did any other group get something like this? Okay, if you don't agree, check and see. Go use, oh,
Why
this
is
is,
it not 130?
yeah,
Wouldn't it be 130?
this should be 0.7. I think maybe this should be 0.7, not 7. Right? Now, can you calculate this carefully?
10 times 1 minus pi.
Oh, okay. So this is the thing. I want you to be very, very careful. I think some of you are reading the formula wrong. It is not n1 minus pi. It is pi 1 minus pi. So look carefully. Pi n. Can I? Sorry, there's no pen here. Yeah, there really isn't. Okay. Can I have one request? When you write pi, don't write your pi like an n. Some people write pi literally like an n, like the capital pi. That's capital pi, the one that fraternity houses use. Right? Not that one. This is little pi. So make it look like a small, like a small side table with a top and two legs. Right? Okay. So pi 1 minus pi over n, not n 1 minus pi over n. All right. So if you calculated this correctly, what do you get? Is there a group that's getting a different number here, right? Because it should not be the case. So if this is the number, then what should be the area on the left of minus 0.04? We have to round it, right? Minus 0.04. Let's go to our z table. Do you see minus 0.04 would be 0, 1, 2, 3, 4. Do you see 484? So the area to the left of Z is 0.44. Now here comes the hard part. Is this the p-value in this case? It is, because it so happens that this is the area I want. It coincides. So you don't need to do anything else. Is this okay? You don't need to do anything else in this part. All right? Let's immediately go do another one, right? This is the p-value in this case. Okay, let's do another one. The other problem I have is, oops, hold on. Okay, this one. Let me get a screenshot of this and put it on here. Okay. Can I have you please start to fill this in so we can compare together? Okay. Can you change some stuff here and answer the question as asked? Okay, so what's theory Z here? This scenario has changed, sample size has changed, everything has changed. But what's the formula for theory Z? Just erase some stuff and put the correct numbers in. So it's always red minus blue, which in this case is not 0.7 anymore, but 0.3. This is a totally different problem. But you are calculating theory Z. And the form C, pi 1 minus pi over n. And the n here is 0. Do you see that? And what is this numerically? Right? What is the answer for theory Z? This one's positive, by the way. Okay? This one's positive. Hmm. 0.053. Anyone, do we agree? Are you all getting this same number with the rest of the class?
We got a different
Oh,
For the first one?
okay. You know what? I think I'm going to check this because I don't want to be showing wrong things.
Okay, thank you.
You can see it is challenging because sometimes it's even the issue that there are problems with calculator use. So I don't want the calculator to be the cause of your problems. So I want to make sure that you can. Oh, where is it? Okay. Okay, so let me once and for all check to see if this answer is correct. This is so scary, okay, because is it not understanding SQRT? I thought it does. Maybe it doesn't. Because I don't see any parentheses problems here, so uh, uh, anyone have any suggestion what we could use, honestly? Really?
No. Is this not looking right?
No, I believe that's right.
Okay.
Yeah.
We're
Yes.
just trying to double check.
So, okay, I'm a little bit concerned if this is you. Just make sure that you see. It takes AI to give us the answers. Right? Because we're too stupid. Okay. But anyway, the point is, we need a computer to tell us. So minus 1.897 or something like that. So I'm going to now, if you made a calculator error, go find out what you did that was wrong, because you don't want your calculator to be the reason why things are not being calculated correctly. Okay, so let me go back to this one. Okay, thank you. So can we change some answers? Now that it's minus 1.89, that's not correct anymore. What is the area to the left of minus 1.89? Yeah, why not ask ChatGPT, what is the area to the left of minus 1.89 on a standard normal distribution table, right? It will give you the answer, I believe. If it cannot, then it has failed, right? So minus 1.89, do you see it here? I do. All right. Can you type it in? What is the area to the left of minus 1.89? Yes, 00294. And is this the p-value? It is. There's no need to process because it is a left side area. Let's finish this one. Is this correct? At least two groups getting the same number, 2.44. Okay, I'm going to just say it's correct, okay? Okay, so 2.44. What is the area to the left of 2.44? Anyone want to tell me? Look at the table. Okay, don't worry about this yet. Just answer this question. What is the area to the left of 2.44? The area is a left table, right?
0.9925.
Thank you. What did you say? 99?
ChatGPT says 0.9925.
I don't want what ChatGPT says. I want what you get from the table. What if one day the computer is down and all you have is a paper-based Z table, huh? Okay.
But it's working.
9927, right? Okay. I'll show you where, okay? 244, right? 244, 9927. Good. So that's the area to the left of 2.44, but the p-value is the right area. So it is 1 minus this one. Did you get that? Now, why do I want a right area? I'll tell you why. Because this hypothesis test was a right side hypothesis test. The other side, right side. All right? So that's how you process that answer. Good. Let's do some more. Here's the two-tailed example. Oh, where are you? Okay. Here's a two-tailed example. Let me screenshot this. Okay, and I'll paste this on Scratchpad again. Okay, so here we are. Okay, can you again calculate theory Z and answer area to the left of? Always, I find this way to be the oops, what happened? One. Where did the picture go? Oy, okay, let me do this again. Okay, let's have you change some things. And please, if these things are making you very confused, don't worry. That's what office hours are for. Please come and I will help you. All right. So, theory Z, can you make some changes? In this situation, what should it be? Something minus something, but what? All right. Always red minus blue on top. So what? All right. Right? 478. That's what you saw. And what's hypothesized about pi? The blue number, 0.5. And therefore, in the square, we have 0.5. And then 1 minus 0.5. And then you have sample size here is 62. And you can use whatever you want. I'm not going to say that word, okay? Anyone have it yet? Yeah, first of all, it's negative. Good. Now, did any other group get something like this? Minus 0.3 thereabouts. Good. Okay, so thank you. So answer me this. What is the area to the left of minus 0.35? You notice that I always go to the left side of things because that's what the table can do. What is the area to the left of minus 0.35? Minus 0.35. 0, 1, 2, 3, 4. Yes, 3632. So can someone type that there? The area to the left of that is 0.3632. Now, do you need to do any processing? But the p-value is the left and right tail areas. So it is what? How do you process this answer? You multiply that answer by 2 because that area is only on the left. But a p-value needs, in this case, because it's a two-sided alternative, so when you want to calculate a p-value, you always need to check what my alternative was. Is this okay? Let's do one final example. So the last one was here. Where is it? Oh, I have so many windows open. Okay. Is this the one? No, this is an earlier one. Let me shut this down. Yes. Last example is here. And here's where we have it. Okay. Okay. So let me paste this here. Okay. Last one. What is theory Z? What is the area? Oy, what are you doing? Okay. Okay. Here's all the text. Can you make the necessary changes? So in this case, What is p hat now? That's right, 621. It so happens that pi is still 0.5. It could be something else. I kept it at 0.5. And the sample size 82 now. And this one was, okay, did any other group get something like this, 2.1? Yes. Oh, you did? Okay, good. I thought it was something else. Okay, good. Okay, so what is the area to the left of, just answer the question. What is the area to the left of 2.19? Now, I mean, you know what? Maybe we'll do you want to do this another way? Maybe we'll do, let's pretend it's negative. The area to the left of negative 2.19 is what? I want to try something new. What is the area to the left of negative 2.1? Now, if you don't like this argument, you can go back the other way and basically, I'm just trying to make your life as easy as possible. If you get the area to the left of a negative number, then you just multiply the answer by 2. So it doesn't even involve subtracting anything. What is the area to the left of negative 2.19? I know that your z was positive. That is correct. But for table purposes, you can flip the sign to get the area first. So what is the area to the left of negative 2.19? Anyone have the answer from the table? Right.
0.0143.
0.0143. Do you agree? Do you all see that? Good. So, but the p-value is the left and right tail areas. And so what do you need to do? You multiply what by 2? You can show your work, you know. Anyone at all? What should it be? The area to the left of minus 2.19 is that thing. You know you want both tails, and so what do you need to do to that answer? You multiply by 2. But can you show me what you multiply by 2? All right. You take 0.0143 and multiply that by 2. So in the remaining time, and in fact, I'll let you off early today. Oh, yes.
Why the people not change to negative?
Yes. You mean the 2.19, right?
Yeah.
Okay. If you don't like this device, then just always do area to the left, do a 1 minus to get the right tail and multiply by 2. But if you want a shortcut, you know this is at 2.19. But you also know that the area is the same on both sides. You can flip the sign just for the purposes of getting the area. I'm not saying z is 2.19 or negative 2. I'm saying you flip it so that you do less work on the table. That's a very good question, actually. I'm not saying z turn into a positive number or negative number or something like that. So let me just very quickly, before we go, I'll just take 2 minutes. Let me summarize what we did today. We learned theory z, which has this formula which I've used many times today. Once you calculate z, you answer a few questions. You need to look at the area to the left of that number. If it so happens that it coincides with your alternative hypothesis, there's nothing else needs to be done. That's your p-value. However, if your z turns out to be a positive number, like 2.44, then it's here. The table doesn't give you this area directly. So if you want, you know what you can do? You can flip the sign and get the area on the other side and immediately get the answer. So I leave it to you. If you don't like this argument of 1 minus, you can always take your positive number, flip it for the table, and get the area and answer that for the p-value. When it's a two-sided test, you find the area on one tail and multiply that answer by 2. Whether a test is 1 or 2 tails depends on the alternative. If the alternative is a not equal to, it's two-sided, any other thing is greater than is one side right, less than one side left. That's it. Okay? So So have a good rest of the day. Please hand in both sheets, okay? And make sure your group names are on the sheet. Let's leave that here. Thank you.